questions that have arisen from the assignment that is currently still open that I want to go over today. It's about, I think, 3 questions. Then hopefully that will help you address them and address things that are similar to them. The assignment's going to be open beyond beyond tomorrow. It'll probably be closed off on Monday because we're not going to get to altitudes today, and there's still some stuff in there that addresses altitudes and ortho center. So we'll get to that stuff, but right now that assignment's not due yet. It will not be due tomorrow either. Okay. But right now we've got this question here. It says find the coordinates of midpoint BC, find the length of AM, and then find the coordinates of centroid P. What your in of course exam would do if we're asking this question is they would just say part C, find the coordinates of the centroid P, and maybe explain yourself on how you've done that. Okay. So in the event of trying to explain myself of how I did that, I would have to find A and B. Does that make sense? So Math Excel is trying to kind of get you into the procedure, kind of pull you through it, but then hopefully we do that enough that we can make the connection of how we would do this kind of collectively all at once just to answer C. Okay? So I'm going to ask us for the coordinates of BC, okay? Coordinates of the midpoint of BC, which is this point right there, okay? How do I do that? Okay. Say again? Alex?
Yeah, it's like y2 minus y1 over 2, then x2 minus y1 over 2.
Careful.
It's like x first, and then y second.
Okay, it's got to be x's and then y's. But you guys are saying minus. So if I minus these, and just think about this, this is going to help you realize if you've got your formula right or not. If I subtract 11 and 9, I get 2, right? Divided by 2 would be 1. So that's saying the midpoint is going to have an x-coordinate of 1. So the midpoint would be on that vertical line right there. Is it? No, I got to add them. I got to add my x's. So 11 plus 9 is 20. Divided by 2 is 10. That makes sense because 10's right there. And then add my y's. So 4 plus 2 is 6. Divided by 2 would be 3. So my y value is on that line. Y equals 3. Okay? Is that okay? Is that how we find the midpoint? Add the x's. Divide by 2. Add the y's. Divide by 2, right? Okay, so now, the next question says find the length of median AM. Well, that's the blue segment. Okay, now, when I say what is the orientation of that blue segment, basically I'm asking what is the slope, and when you find that slope, then what kind of line is that based off that slope? So what would my slope be of that line? 0. And because I have a slope that is 0, that means it is a what kind of line? It's a horizontal line, okay? So the orientation of that line is horizontal, okay? So when I want to find the distance of a horizontal line, do I have to use that long distance formula? x2 minus x1 squared plus y2 minus y1 squared, all square rooted. Do I have to do that? No, I just subtract the x's here, right? I just take 10 minus 1, 10 minus 1, and that's giving me the length of the blue segment to be 9, right? Does that make sense to everybody? You can use the distance formula, but you're going to be doing work that is unnecessary. And that's what I think one of the most important things about mathematics and understanding mathematics is to know when the right work is appropriate and when the wrong, when the right work is appropriate, and when we can use shortcuts. Okay. So that's 9. Now here's the overall question. Find the coordinates of the centroid. So the centroid is going to be, is the centroid closer to the vertex or is it closer to the midpoint? Midpoint. It's closer to the midpoint. So my thought is that's probably in that purple region somewhere, right? Okay. So what we need to do is realize that the centroid is, by the theorem, it is located 2/3 of the way from the vertex to the midpoint, right? Well, what is the distance from the vertex to the midpoint? We just did it right there, right? It was 9, right? Okay. So isn't the centroid going to be 2/3 along that route? So what is 2/3 of 9? 2/3 of 9 is 6, right? Okay. So does it make sense that the centroid is 6 units away from A? So if I count 6 units away from A, isn't that going to be at 7? It's right there. 7, comma 3. Does that make sense? Okay. So the way that the author of this structured this question was to use that 2/3 with 9. If my goal is just to find a centroid and I don't care how I go about doing it, is there a better way or an easier way? You guys remember what that kind of demonstration I showed you yesterday showed you could do with your X's and Y's? Okay, good. Add all the X's. So that one, that one, that one. If I add those up, I get 21, right? What's 21 divided by 3? 7. Add your Y's up. 3 plus 4 plus 2. That gives you 9, right? 9 divided by 3? 3. Is that the same ordered pair that we found using the other technique? Okay. So you've got options. Okay, at least with this particular question. Now, if that line was not horizontal or vertical, if the median was had a particular slope to it other than 0 or undefined, the procedure that's laid out in this question in parts A, B, and C would be very difficult to work with. Okay, and you would want to use the average of the X's, comma average of the Y's. My suggestion to you: always use the average of the X's, comma average of the Y's. Okay, a lot of textbooks don't actually show that. They don't present that formula for the centroid, and I'm not sure the purpose of not showing it, but I think we can use it and get to those solutions, those centroid locations, a lot quicker that way. This one here is using the same information, but I think through just conversation with people that have had questions, kind of one-on-one during Wildcat time, we're not 100% confident on where we put the 2/3 or the 1/2 or the 1/3 in our equations when we're setting them up. Okay, we've been talking about the idea that if I want to shrink something, okay, then that's the object that I need to put the 1/3, 2/3, or 1/2 with. If I want to make something enlarge or grow, then I would put the reciprocals of 3 or 2 or 3/2 with that. Okay, I think that's maybe the best thing to think about in regards to where I put those fractions. But let's think of this, and this is going to be something you guys have to understand so that you can be successful in every other math course that you ever take. Let me increase the font here real quick. All right, if I write out the theorem that was being discussed in the centroid, okay, basically the centroid theorem says that the distance of I mean, I don't do a whole lot of things just to do them. I would probably, everything that I write down, I would probably think that that'd be important to write down. Yeah. All right, so the distance from the vertex to the centroid is 2/3 the length of the median. That is what our theorem 2 days ago said. The distance from the vertex to the centroid is 2/3 the length of the median. Okay? That is how 90%, probably even more than that, theorems throughout all of mathematics are going to be presented. They're going to be presented in English with you, right? Or in words. Does that make sense? They're not going to give you a picture and then say, here's the fraction you use in this picture, like I did with GeoGebra and showed you the parts that we can compare and see that relationship of 1 to 3 or 2 to 3 or 2 to 1 or whatever. They're going to give it to you as concisely as they can. They'll try to say the most with the least amount of words. And then we have to interpret that, what that means maybe algebraically for us. Okay? So, we're going to come back to that in a moment because we want to look at HD and CD in this picture. HD and CD. And my goal is to come up with an expression for a CD. Okay, so we're at CD. Obviously, we know they're not equal. CD and HD are not equal right now. But if I look at this, they're trying to come up with an expression. Given HD, can you come up with an expression for CD? Well, let's link CD and HD first. This is very similar to the examples we did in class yesterday. I don't need this segment anymore, right? Okay. But I do need CD and HD. So CD is that blue distance, right? HD is that red distance. Okay, so when I look at D to C, is that the vertex to the centroid? Okay, so C to D. So what I'm trying to get at here is that blue distance, underline it blue, that blue distance is that right there, which is this right here, right? In mathematical terms, what does that word right there mean? Equal. So, for our particular situation, vertex to centroid, CD is 2/3 the length of. What does the word of mean in mathematics? No. Multiplication. Okay? So, 2/3 of the median. What's the median? HD, right? So we see that CD is 2/3 of the median, and that puts 2/3 on the right spot. Okay? You guys remember back to Algebra 1 when you did things like that? You took a English phrase in words and converted it over to an equation or an expression. Okay? We use words like sum or product or difference, of and is. Okay? And we use those to change things from words to equations, expressions. That's going to be the process from here on out. In this course, Algebra 2, all the time in Algebra 2, and every story problem that you do in that course, college algebra, trig, any integrated course that you take, and so forth. Okay, so high school math is going to require you to know that when I read an English phrase, there's key words like is and of and difference and sum, quotient, that kind of thing, right? Does that make sense? Okay. That should kind of go along with or mimic what we've been talking about. Okay. If I look at the blue segment and the red segment, which one is longer? The red one. Okay. We knew based off the comparisons that we gave yesterday, the day before, that because we're comparing the vertex to the centroid to the whole median, we know we should use the 2/3. So now the idea, since the median HD is longer, can I multiply that by a number between 0 and 1 to shrink it down to the blue? Does that make sense? And is that what my equation is saying? Take HD, which is the longer segment, multiply it by a fraction between 0 and 1, and shrink it down to something that is smaller. CD is smaller. Does that make sense? Yep. So once you can set that up, then it's just a matter of saying, okay, well, I'm trying to solve for CD and trying to write an expression for that. So then let's substitute HD with 24x plus 6y. What's 2/3 of 24? 16. Okay. And then plus, what's 2/3 of 6? 4, right? Is that okay with everybody? So we're all good with multiplying by fractions? 2/3 times 24? All right. I think the most difficult question on there is this, and I don't know why they don't ask to find the centroid. They just want you to find the equations of the medians, which will be a question that I ask you on test. Time consuming. And it can be very time consuming. It can be messy if the overall goal is to find the centroid's location. It can be even a little bit more work than what this question is asking. But I want to go through this. I want you to get practice at writing equations. I want to talk about the algebra that is kind of the process of foreshadowing when I'm doing algebra and thinking ahead a little bit and say, okay, well, if I choose this point, what math is that going to provide? Or if I choose this point, what math is that going to provide? I also want to talk about the fact that a lot of people want to just start counting. We're going to need slope here, and want to count. And this problem, it's not terrible if you count between the right things. But I want you to understand that formulas are your catch-all. Formulas will always work, right? Okay? So if you're uncertain about using the counting techniques, because those only work when you have integers as ordered pairs, the formula is going to be the best. And the counting even fails when I have integers that are really, like if I give you ordered pairs that were like, 1005, 2031, and another one that was, 500, 13, you're not going to want to count between those sets of ordered pairs, right? Okay, you're not going to want to graph that. So you're going to use the formulas because the counting process, the shortcut process, has kind of a boundary. At some point, it's going to be tedious and a pain in the butt for you to do that. Okay, but the formula will always work. So that's what I'm always going to use in class is the formulas. Okay, so remember that in order to find maybe the equation of that line right there, I need 2 points on that line. Okay? Well, down here they don't give A, but what is A's ordered pair going to be?
0,
0, 0. Okay? Now, M up here, what's M's ordered pair going to be? 8, 5. Okay? Because M is the midpoint, right? So these are meeting, and so that has to be a midpoint. So I take 6 plus 10, 16, divide by 2 gives me 8. 10 plus 0 is 10, divide by 2 gives you 5, right? I'm just going to go through them. I'm going to find the same thing for that point there. Okay, so that's going to be, what, 3, 5? Is everybody okay with finding those midpoints? And this one down here in green would be 5, 0? All right, so we're going to find the blue equation, and then we'll go back and we'll find this one here, which I'll color red in a moment, and then we'll color this one here green, and we'll find all three of these equations. So again, the number one thing, the number one tool you're going to want to use is this. Okay, and I need slope, right? So I'm going to find a slope of the blue line. So slope of the blue line uses 2 points, right? Use 2 points that you know are on that line. Do not get silly and say, okay, and let me just go to GeoGebra to show this and explain this concept. If I've got 0, 0 and 5, 8 as my segment that I'm trying to find the slope of, obviously you can count up 8 and over 5, right? So I know my slope is rise over run. So I think I got this backwards, doesn't it? 8, 5 was the point. So I count up 5, a rise of 5, and over 8, so a run of 8, right? So 5, 8 should be my slope. I'm seeing some people do this, though. They're getting, like, they're getting to, like, here and say, okay, I think that point right there, I could go up 2 and over 3. And I get a slope of 2/3, okay? But if you were to zoom in right here, do you see how that red line is not at the intersection of those grid lines? Okay, and with a lot of pictures that you're getting in Math Excel, they're not great pictures. There's not a whole lot of great detail. It's very pixelated, that kind of thing. So you're making assumptions that are not true when you do something like that. You absolutely know 0, 0 is on that segment, right? Use that point. You absolutely know 5, 8 is on that segment, right? Use that point. Don't try to choose anything. Don't try to be cute by choosing points on the interior. that you're not confident in, okay? Again, if these points were nasty, if they were fractions, okay, if they had square roots in them, even if they were really, really, really big integers, the rise over run counting technique is going to fail you, okay? So I'm going to just do the slope formula. y2 minus y1 will be 5 minus 0. 8 minus 0 gives me 8, right? And if we understand that, if we can do mental math of subtraction, guys, that should actually be fast. People want to do the counting because it's faster, right? Well, 5 minus 0 and 8 minus 0, if you can't do that math in your head pretty quickly, I think we've got issues, okay? So 5/8 is my slope. Now I'm going to plug that into this formula. Y minus y1 equals 5/8 x minus x1. Okay, now, what would you want to put in there? What are my options? Okay, well, my options are any point that's on the blue line, right? You know 2 points on that blue line, right? So there's no need to go trying to find anything else on the interior. Don't try to find a new point that you haven't used. Use one of those 2 blue ones that we have up there. Now, think about it, though. If we want to do work that is minimal, okay, we want to be efficient, would you rather take y and subtract 5 from it, or would you rather take y and subtract 0 from it? 0. So if at any time that when you're creating the equation of line, you have the ability, because your line has a point on it that has a coordinate of 0, choose that one, okay? We're just lucky enough here to see that we get 0, 0, so both x1 and y1 can be that. So I put 0, 0 in here. What's y minus 0? 0. X minus 0? Just x, right? So y equals 5/8 x is the equation of that blue line. If you would have chosen the point 8, 5, you can work through all the work and you're going to still get y equals 5/8 x. Okay? It's just going to take you a little bit longer time to get there. Does that make sense? So that's the whole thing about mathematics, understanding your options and doing a little bit of foreshadowing. Hopefully you realize that, you know, adding 0, subtracting 0, that is preferred, okay, over anything else. Now I want to do the same thing for that red line. Okay? So now I'm going to go y minus y1 equals m times x minus x1, right? I need my slope. So again, doing that mental math with 5 minus 0. 5, right? 3 minus 10, negative 7. Now choose an x1, y1. Do I want to choose that one? Or do I want to choose that one? That one. Okay? So now I'm going to go y minus 0 is equal to my slope, negative 5/7, x minus 10, right? That's going to end up giving me y equals negative 5/7 x plus 57. Okay. The number one thing people want to do with this, and just kind of watching, underwriting this stuff down, is that they don't like fractions, so they do this. Type that number into my calculator, and it gives me negative like 0.7. Type this into my calculator, and it gives me like 7.1, I think. Now, I'm rounding those things. Does that make sense to everybody? And this is the logic of why I don't want to do that. If I were to type that equation or use that equation, okay, so y equals negative 0.7x plus 7.1, okay, we're saying the point 10, 0 should be on that. We're also saying the point, what was it, 3.5? 3.5 should be on there. Okay? Now, if I look at 3.5, and this is just kind of a coincidence, 3.5 does show up on there. Okay? If I zoom out, go back to the other point, 10.0, is 10.0 on that line? No. Okay? So when I round that fraction, I actually create a line that does not have the points that I use to get that line. Does that make sense? Okay? So that's why we want to keep these things as fractions. I don't ever want to change them. Okay? Now, I rounded pretty, I was pretty sloppy with my rounding, pretty liberal with it in regards to cutting off to the first decimal place, right? If I went two or three or four or five decimal places, that's going to snug that line up to A even closer, but it's still not going to go through A. Does that make sense? Okay, I need all my decimal places to make that point or make that line go through that point. So getting all my decimal places, the easiest way to do that, and sometimes the only way to do that, is to actually leave it as a fraction. Okay, whether it's a improper fraction like 57ths or a proper fraction like 5/7. So that's the equation in the red one. Is that okay with that? I think those are little Algebra 1 topics that we have to talk about because of how much that stuff is used later on throughout all of your math classes. All right, so now let's do that green one. So I go y minus y1, m times x minus x1. Slope here again, be 10 minus 0, 10 minus 0, 10, and then 6 minus 5, 1. So slope is 10. Now what point would you use, 6, 10, or 5, 0? 5, 0. So I get y equals, be my slope of 10, x minus 5. So that gives me y equals 10x minus 50. Okay? Those equations are the only thing that this question is asking for. Now I want to go a little bit further. Okay, and I want to actually find the centroid here using the algebraic equations. Well, this is a system, right? Where those lines intersect, if I use a system of equations, I can find out where the centroid location is. Of these three equations, the blue one, this red one, or this black one down here, which two would be the best to choose, or which one would you leave out? Trey? You're going to leave this one out, right? Because it's a nastier setup, it's nastier fractions than the other two, right? Okay. If I have 5/8 x equal to y, and I have 10x minus 50 equal to y, where they cross, shouldn't these expressions be equal to each other? Okay. Now, if I would have thrown in the 7 in here with the 5/8, then I got to multiply everything by 7 times 8. If I would have thrown in the 5/7 with the 10x minus 50, I got to multiply everything by 7, and it just gets, it's messier. Okay. What can I multiply everything by here to get the fraction to go away? 8, so we get 5x equals 80x minus 400. Gives you negative 75x equal to negative 400, right? So x is going to be 400 over 75. How many times does 25 go into 75? 3. How many times does 25 go into 400? How many times does it go into 100? 4 goes into 104, so how many times does it go 400? 16, right? So 16 thirds would be the x-coordinate of that point, that centroid up there, right? Are these equations then equations that will find y for you? Once I know x? Foreshadow a little bit. Would it be kind of messy to plug in x here, multiply, and then add that stuff? Would it be messy here to multiply by 10 and then subtract 50? Would it be less messy to plug in x right here? Because I don't have to add or subtract anything to that, right? So if I plug 16 thirds in there, 5/8 times 16 thirds, okay, 16 is 2 times 8, right? Is that 8 on the bottom and that 8 in the 16 going to cancel? Sure. So you're really left with 5 times 2 up top, 1 times 3 on the bottom, right? And that was what y is equal to. So we now have this point right there, this centroid, being located at 16 thirds, comma 10 thirds. 16 thirds is 5 1/3. Does that look like it's an x value? So 6 is that x value right there. Does that point look just to the left of it? 5 1/3. 10 1/3, or 10 over 3 is 3 1/3. Okay, if I go over on the y, it's just above 3 on my y-axis, right? So it looks right, okay? So that is the centroid of that triangle using that technique. Was that a long process? Okay. Add all your x's up of A, B, and C. What do you get? A, so 0 plus 6 plus 10 gives me 16, right? Take the average of that to give you 16 over 3. Now do it with your y's. 0 plus 10 plus 0 gives you 10 divided by 3. It gives you that, right? So that's exactly what we did yesterday with the that demonstration at the end of class to kind of show you that you don't want to go through all that algebra every single time they actually find a centroid, right? It's so much easier to find the average of your x's, comma, average of your y's. Okay, so that's hopefully the technique you use. But what I like to do, what I like to do in all my math classes is allow you to gain an appreciation for these formulas. Okay, hopefully you now have an appreciation for x1 plus x2 plus x3 over 3, comma y1 plus y2 plus y3 over 3, because it saves you probably about 10 minutes per problem. Okay, and I think you're gonna find out when you take other science classes, when you take Algebra 2, when you get into a calculus class, you have different teachers, you're going to find out that that's what a lot of them do, is that they try to get you to do it the long way, okay? See the long way, see how it works, but then if there's a shortcut, allow you to start using the shortcut because it gives you an appreciation of that long way and an understanding of where that shortcut comes from, okay? I hate giving you shortcuts and not telling you where it came from or not telling you when it works, why it works, that kind of stuff, because I think that can get you in trouble if you don't know those things, okay? But by all means, when you're asked to find a centroid, I'm not going to ask you to do it this way. I'm going to ask you to use the averages, okay? Do not use the equations. It takes too much time. All right? In your email, there's a homework assignment. It's not due until Monday, okay? But start working, because I'm going to probably give you some extra assignments tomorrow, too, or maybe not tomorrow, but maybe tomorrow. I don't know yet. I haven't decided yet. Okay, depends on how far we get into class tomorrow with altitudes. I'm also leaving 5-4 right now open because there's some questions about altitudes in there, vocabulary mainly, that you haven't been able to address yet through class instruction. So all the assignments that are open, which is just 5-4 in Math Excel, and what I sent you in your email, they're going to be due on Monday. Okay, so just keep that in mind. That's all I've got for you today. So you guys can work on that for the next couple minutes. Yes. Didn't you go to the restroom beginning class?